Hello. This is a very informal video about uncertainty propagation. Uncertainty propagation is what I usually find that most people have problems on, and it's not really a difficult concept to grasp, but the actual propagation, the actual calculations, is what sometimes messes some people up. So I'm just gonna do a bunch of problems, let's say 5 problems, and go through the calculations. Every time I do a problem, though, what I want you to do is to pause the video, work on the problem yourself, and then you could resume the video, and then I'll do the solution. And before I do go on into the actual problems, I'm gonna explain a couple of things. Uncertainty isn't really it's something I sort of expect you to know, but basically the general strategy towards uncertainty propagation is that you would, let's say you have a function or equation. Let's say we have this crazy equation right here, and we want to find the uncertainty of delta A, when we know delta X, we know delta Y, we know delta Z, and we know delta B. These deltas are just uncertainties to these associated variables. In order to find the uncertainty of delta A, we would sort of work in our usual orders of operations. The way I learned it in elementary school was PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. You would sort of just follow this route as if you would do a regular calculation, but instead of regular calculation, it's uncertainty propagation. So when we're starting off, we would start with parentheses, so we would start with everything in here, and therefore we would actually treat these terms by themselves. So first we would start with division, which is z divided by b. So first we would find the uncertainty of z divided by b, and then after that you would find the uncertainty of 5y, so the uncertainty of 5 times y. After you find that uncertainty, you would move on to the uncertainty of this whole parentheses, which is delta 5y plus z over b. And then you would do your multiplication rule with 4x, so you could get the uncertainty of 4x 5y plus z divided by b. And then same thing over here, you would find your uncertainty of xy. And then to find your uncertainty of a, it's literally just this. It's literally just that. You would combine this. So that's the general strategy. But enough of this general strategy. I'm going to be actually doing some concrete particular problems. And as I said, every time I go to a new problem, just pause the video, work on it yourself, and then I'm going to give you the solution. For our first problem, we're going to find the uncertainty of a force. So we're going to have F equals ma. We're going to have to try to find uncertainty of F if we know the uncertainty of the mass and the uncertainty of the acceleration. So let's say we have a particular experiment where we have some kind of I don't know, let's say we have a ball with a certain mass m, and we measure its acceleration. We want to find the force of it, and therefore the uncertainty of the force. Before I go on to the strategy, pause the video. I'm going to sit here for a few seconds, and hopefully you pause the video and work on the problem yourself. Okay, now I'm back. Basically, in this, in order to find the uncertainty F, you would have to use the multiplication rule, and I'm going to write it off to the side over here. Multiplication rule, which is if you want to find the uncertainty of x times y, then you would have to take the uncertainty of the first thing multiplied by the center value of the second thing, and then you would add the uncertainty of the second thing times the regular of the first thing. So let's apply this to over here. To find the uncertainty of the force, we're going to have to find the uncertainty. We have to take the uncertainty of the first thing, delta m, and multiply it by the regular of the second thing times a, plus the regular of the first thing, m, times the uncertainty of the second thing, delta A. So this is what your answer would be. Simple enough. That's just one rule. Let's go on to our second problem. Number 2. And I promise these are going to get harder. Just these two first ones, I just want to make it a little easy. The second one is very similar. We're going to have to we're going to have to find the uncertainty of a force if we have m times g. So let's say we have like a little object and it's falling, and it has a mass m, and we know that there's a force of gravity which is equal to m times g. And we want to find the uncertainty of this thing if we know the uncertainty of m. However, before you go on to attempt this problem yourself, g is actually a coefficient. It's a constant. It doesn't have any uncertainty. So I would just let you know right there. So now just work on the problem yourself right now, and then I'll be back in a couple of seconds with the resolution. Okay, now I'm back. In this problem, we will have to use the multiplication rule, but really, like, you don't really need to. There's sort of like this hidden, like, I call it the coefficient rule, this hidden coefficient rule. So coefficient, if we have the uncertainty, if we want to find the uncertainty of a coefficient times a variable, c times x, we would literally just move the c outside like that. So basically, this is just going to look like c times delta x. You have your constant, and then you're going to multiply it by the uncertainty of the variable. So implying that sort of rule to this kind of question, we will literally just have delta f equals the constant g multiplied by the uncertainty of the variable delta m. So this is what the answer is. Now I'm going to go on to the third question. This is going to be a little bit more difficult. It's going to require multiple steps. This is where like stuff gets real, I guess. Let's say we have equation 2 pi times L over G. I believe this is the period of an oscillating pendulum. Let me see. Let's check the units. Length is in meters. G is in meters per second squared. Yep, this is the period of a pendulum. So we have like a little pendulum. It's spinning over here. It's going back and forth due to the force of gravity. And this has a length L. This has a length L. How would we find the uncertainty of this thing? Well, that's for you to figure it out for this next few seconds. So pause the video and work on it, and I'll be back in a couple seconds. Okay, so now I'm back. In order to do this, you have to use the square root rule, and it's sort of tempting to use the division rule. I'm gonna put it down over here just in case, like as a reminder. Division rule. Division rule is actually just if you have the uncertainty of x divided by y, that's going to be equal to the uncertainty of x divided by x plus the uncertainty of y divided by y, and then I believe it's x times x over y. I believe that's what the division rule. But in this case, g is just a constant. G is just a constant. Actually, more so, when you have L over G, it's actually just L times 1 over G, and we just treat this thing as a constant. Like, you could really just use your coefficient rule over here. So there's actually nothing much to worry about in this problem. The only thing that is sort of new, I guess, at least in terms of this video, is the square root rule, which is right over here. So the square root rule is basically a square root. The uncertainty of, let's say, the square root of x is going to be equal to delta x divided by 2 times square root of x. I believe that's what it is. Anyways, applying that rule to problem number 3, we just have to find the uncertainty of this thing, of whatever's in the middle. So following PEMDAS, it would be like the very first thing over here. So the uncertainty of L over G is literally just the uncertainty of this thing is just going to be delta L divided by G. And then to find the uncertainty of the square root, this is a really bad diagram. Yeah, like that. Okay, the uncertainty of that thing would just use this this square root rule. So we would just have the uncertainty of whatever's inside, so L over G, divided by 2 times the square root of whatever's inside, so that's just L over G. Let's just like clean this up a little bit. Let's draw an arrow. Nah, I'm gonna not draw an arrow. Let's just clean this up a little bit. We can move this G down to the bottom, so we just literally have delta L divided by, actually, we could do this. We can split things up. Right over here, delta L square root of G divided by G times 2 times the square root of L. Does that make sense? Wait, hold on, let me see. If we put the G on the bottom and we put the G on the top. Yeah, that makes sense. Okay. And then with a period, in order to get the uncertainty of T, if we want to find uncertainty of T, then we would just use the coefficient rule, because 2 pi is just a coefficient. We would use this rule, and really our answer would be delta T equals 2 pi times that. And we can actually cancel these 2's out, because there's one over here and there's one over here. This is your answer. Now, I'm sort of running out of room on this file, so let me just like erase a couple of things. Okay. Did I erase the square rule? Let me put that back in. Delta x square root of x. Okay. Anyways, sorry if this is like a really messy video. Let's get to our fourth problem. Problem number 4. What I have here is a little more complex. We have the velocity of something, the exit velocity times 2g h initial minus hf, I believe. I'm not sure, but basically this comes from like if we have this equation is related to an experiment where we have a little ramp. Let's say we have a little ramp and there's a ball going down it, and it sort of just like leaves over here, and like let's say this ramp is like sort of like elevated. This would be delta hf, and this would be h initial, I believe. I don't know, it doesn't matter, but that's basically where it comes from. G is a constant, and I would just let you do this problem by yourself. So pause the video and I'll be back. Okay, so now I'm back. In order to solve this equation, to find the uncertainty of delta VE, we would have to start from the middle. This requires the addition and subtraction rule. I don't know if I should write it down. I'll also write it down. Addition and subtraction rule. Basically, if you want to find the uncertainty of x plus or minus y, then you would literally just have the uncertainty of both. So this is what it would be equal to. So using that rule, we would literally just have the uncertainty of hi plus the uncertainty of hf. This would be our uncertainty of everything in that parentheses. Next, we would distribute this 2g, which is just a constant, and that would use our coefficient rule over here. So you would literally just put 2g and then parentheses of that thing. After that, if you want to find the uncertainty of delta VE, you would use the square root rule, because this whole thing is under the square root. So you would use this thing, and that would require putting the uncertainty of whatever's inside, so that's all of this. You would divide it by 2, and you multiply it by this whole equation. So that would be just 2g times hi minus hf. And this would be our uncertainty of VE. Now we're going to go to our last question, number 5. And this is going to be at least the most complex that I have on the list. With this whole equation, we just want to find delta omega f if we know the uncertainty of this thing, uncertainty of this thing, uncertainty of this thing, and uncertainty of this thing. Now, a quick note before you start doing this problem. Let's say we use the same scale to find these masses and use the same ruler to find these. You would use, you would literally just like, let's say the uncertainty of all of these things is equal to delta r, and the uncertainty of all of these things, of all the masses, is just delta m. So the uncertainty of MC is just delta m. The uncertainty of MR is just delta m. The uncertainty of capital R is just delta r. The uncertainty of RI is just delta r, and the uncertainty of RO is just delta r. So pause the video and work on the problem yourself. Okay, so now that I'm back, I'm going to give you the solution. First off, we would start from sort of the innermost parentheses, which is just here. And actually, before I start off, let's clean this up, because if you clean it up, your algebra is going to be a lot easier. So what we could do is factor a 1/2 out of the whole equation. And I'm not solving the uncertainty yet. I'm just literally just making it simpler for me to comprehend. All I did here is just factor out this 1/2 to put it over there. Now I could do uncertainties. So to find the uncertainty of this whole thing, you start from the innermost thing, parentheses, which is this. But before that, we have to find the uncertainty of these squares. That would require the multiplication rule. It's the application of the multiplication rule, which is this thing. But since it's just a square, we're sort of just like, it's just common, like with squares, the uncertainty of squares. It's really just going to be equal to delta r times r times 2. This would be the uncertainty of ri squared. It's going to be this. That's an application of the multiplication rule if you do it on by yourself. The uncertainty of this thing is also going to be the same thing. And then using our addition and subtraction rule, we can combine this to get the uncertainty of this whole parentheses is going to be equal to 4 times delta r, r times delta r, because I added these together. Now, let's just keep moving on. If you use our multiplication rule of mr times this whole thing, I'm sorry, we would get the uncertainty of the first thing. So that's just delta mr, actually just delta m, times the regular of the second thing. So that's just ri squared plus r0 squared. And then after that, you would add the regular of the first thing. So that's just mr. And then the uncertainty of the second thing, which comes from this, times 4 r delta r. And if you want to clean this up a bit, because this 4 is like annoyingly like over there, I was just going to rewrite it over here. Sorry, give me a sec. R r delta r. Okay, now we have to find the uncertainty of this thing, which requires an r squared. So the uncertainty of r squared, that's just going to be 2r delta r. And to find the uncertainty of this whole thing, you would use your multiplication rule again to get the uncertainty of the first thing, delta m, times the regular of the second thing, r squared, plus the regular of the first thing, mc, times the uncertainty of the second thing, which is 2r delta r. So this is the uncertainty of that term. Now all we need to do is add these two, use the addition rule to combine this whole thing inside this parentheses. That would require the addition rule. So you would take the uncertainty of this thing and the uncertainty of this thing and combine them by adding, and you would get delta m r squared plus 2 mc r delta r plus delta m r I squared plus R O squared plus 4 MR, move this a bit, R delta R. And then, after that, we would still have to distribute this 1/2. That's just using the coefficient rule. So we could just put this all under a parentheses and put 1/2. And this would be equal to omega f, the uncertainty of omega f. This is our whole answer. Let me zoom out a bit. This is our little nice looking expression for delta omega f. So basically, what I did all over here is just a bunch of problems. I hope it makes sense. Please tell me in the comment section below if none of this still makes sense. Again, what I really recommend for uncertainty propagation for studying it is literally just doing more practice problems. Like literally just go throughout your textbooks, your lab manuals, and look for random equations and try to find the uncertainty of them. But that's really it. It's just practice. It's a skill. It's just algebra or computation or whatever. I don't know what the right word is. Probably computation is the best one, but it's propagation as well. I hope that this video makes sense. I hope everything is fine. And thanks for holding on this long if you're up to here, because this is like the first kind of video I guess I did ever on physics. So, and I'm not really good at teaching, or I don't think so. So, I hope you have a good day and enjoy life.